Hello, and welcome back to another episode in the Dark Mart Dev Log series. During this patch, I worked on creating a pathfinding system for the enemies, adding obstacles into the map, and as a result of these changes, fixing the spawning system. Let's talk about some of the changes. The biggest change is the pathfinding system. Previously, all enemy movement was calculated as a direct line straight towards the player. This can be acceptable in some cases, but in Dark Mart, I wanted something a little bit more sophisticated. I wanted to add obstacles onto the map to create a more interesting environment, rather than a big empty area. Introducing obstacles into the map would create a more interesting dynamic for the player, where they may have to think and react to what is happening around them. Godot has several pathfinding solutions built into it by default. There are a number of tutorials online explaining how you can implement them into your game. I chose to go a different route and try to build my own pathfinding system in GD script. I could probably save time by using one of the Godot pathfinding solutions, but it's my goal while developing this game to learn more about coding. This seemed like a great opportunity to get some experience building something that I would have considered too complex to attempt in the past. How could I create a pathfinding system for Dark Mart? Dark Mart is a top-down, tile-based game with active combat. I needed a tile-based pathfinding system that could seamlessly allow enemies to switch between navigating and interacting with the player. Creating a pathfinding component node which could be attached to anything that needs to be able to navigate the map seemed like a good idea. When moving, the subject can request a path from the pathfinding component, sending its position and target position. Then, the pathfinding component reads the map using an algorithm and checks tiles outwards from its starting position, moving towards the target. Once it is able to successfully create a complete path to the target while avoiding obstacles, that path is sent to its entity, who begins following the points towards its goal. Let's look at an example to visualize what is happening. Say that an enemy is trying to chase the player through some trees. It can't move directly towards the player because there are obstacles in the way. It will send its coordinates to the pathfinding node as a start position and the player's coordinates as the target position. Then the pathfinding node will use an algorithm to check the tiles outward from the starting position. Tiles are given a weight rating as they are checked. Tiles that are ranked as closer to the target destination are checked first. Tiles that contain an obstacle will not be considered for the path. Once the target destination is reached by the pathfinder, it adds the coordinates of the tiles traversed to an array. That array is then handed back to the enemy, and the enemy can use it as a path to get to its destination by following the coordinates sequentially. If this sounds like a lot of computation to get a path to follow, you'd be right. One of my biggest struggles implementing this pathfinding system was getting it to run efficiently. It worked okay with a single enemy on the screen. However, as I added more and more enemies, it quickly became a problem, and I was experiencing a lot of frame drops. The debugger tools in Godot were essential in helping me track down some of the bottlenecks and find solutions that would help it to run better. One very big slowdown came from reading the map when searching for a path. Each Pathfinder node needs to check an undetermined number of tiles. They need to keep a list of tiles that have been checked, including information like their coordinates and if the tile is blocked or not. For this purpose, I created a special node which I called a path node. As the Pathfinder checks the surrounding tiles, I had it create a new path node and add it to a list to store the information about the tile being checked. This could result in dozens or even hundreds of nodes being instantiated while pathfinding. Multiply that by a number of enemies, and I think you can see how this could get out of control quickly. Researching what I could do to make this less extreme, I discovered a technique called object pooling. The idea is that you create a pool of objects from which to pull before you need them. Then when it's time to use them, you save time on processing by just grabbing the next object in the pool and sending it where it needs to go. Using an object pool for my path nodes significantly improved performance. But unfortunately, it still wasn't enough. I couldn't manage to have more than a couple of enemies on the screen at a time. My pathfinding code was just not performant enough. However, I didn't really know how to make it better. After all, this is basically a learning project for me, and I have no real game development or programming experience. What I was able to determine based on using the debugger in Godot is that when too many enemies tried to call the pathfinding code at the same time, they could not all finish before the end of the frame. This could lead to some crazy frame drops, causing massive lag spikes in the game. I was feeling pretty defeated and just about ready to give up on this whole creating my own Pathfinder in GDScript thing, when suddenly I had an idea. What if I created a limit to the number of paths that the game allows created per frame? Some entities would have to wait a couple additional frames for their path, but surely that would be better than giant lag spikes and crashing the game. To approach this idea, I created some functions to act as a pathfinding manager. A queue is created when the level starts. When an entity needs a path, it sends a signal to the pathfinding manager requesting a path and placing itself into the queue. Every frame, the pathfinding manager approves a few paths, limiting the total number to an amount that will be able to finish within that frame. Each frame, it will work its way through the queue until every entity that has requested a path has received one. And after adding this queue, it worked a lot better. The game could run without frequent frame drops and lag spikes. However, there are still plenty of flaws with my pathfinding system. I'll be exploring more ideas in the future, and I'll probably try working with the built-in pathfinders to try to get some ideas about how to improve mine. I could go on about the pathfinding system, but in the interest of not making this video too long, I'll stop here for now. Let me know if you would like to hear more about this topic, and perhaps if there's some interest, I can make another video about GDScript pathfinding and maybe get into the code a bit. Once these changes to the pathfinding system were complete, it allowed me to start putting obstacles onto the map. Right now there are just trees, but in a future patch I will be adding more types of obstacles. Now that obstacles were on the map, it was possible that during spawning, enemies could end up stuck directly on top of an obstacle. To fix this, the spawning system was updated. It will check to see if the location it's intending to spawn an enemy on is a passable tile. If it is, the spawning is allowed. If not, a different tile will be located and the process will repeat until an acceptable tile is chosen. Finally, I also worked on fixing the Y sorting for the tree objects. Specifically around the boundaries, it was necessary to use 2 tile map layers. Since my tree sprite is a single object, placing 2 trees right next to each other where they are overlapping cannot be done on the same tile map layer. Using 2 tile map layers allows trees to be placed in a dense arrangement, creating the dense forest look I was after, and also creating a wall that prevents the player from moving outside the area. Depending on the arrangement, this could be a bit tricky to ensure that the Y sorting appeared correctly. In the future, I might try to make some additional sprites that could be tiled to create a forest look on a single layer. Those are the notes for the new update for Dark Mart. If you want to try the game, you can play it on desktop in the browser on itch.io. Thanks for watching. I'll see you next time.